very pleased to inform you today that after extensive research, I've been able to formulate an opinion on your predicament. I feel that you should in fact have children. Not only is having children a wonderful experience, but based on my research, the two of you are fairly unlikely to produce offspring with cystic fibrosis. Let me walk you through the process. First, let's make a little bit more sense of the gene involved. Cystic fibrosis is a gene that's carried on the 7th chromosome and can obviously cause serious health issues for the affected individual. Each parent of an individual will have a genotype of cystic fibrosis, as well as many other characteristics. Due to the fact that cystic fibrosis is an autosomal recessive gene, the genotypes displayed will not identify gender as they do in sex-linked conditions. An individual with cystic fibrosis will have a genotype of little c, and a healthy individual's genotype would be big C, big C. Both of these genes are known as homozygous because they are two copies of the same allele, represented by a letter. A carrier would be big C, little c, which is known as heterozygous because the letters, or alleles, are not the same. Regardless of family history, everyone will have a cystic fibrosis gene. Their alleles, or versions of the gene, are what make up their genotype and determine whether or not they will have the condition. More specifically, they will pass on a healthy big C or an unhealthy little c. Recessive condition is when an affected individual must have two copies of the allele. In other words, if either of their parents passes on a healthy allele to their offspring, they will not be affected, though they may become a carrier. What you see here on the board is known as a pedigree of your families. The circles are females and the squares are males. Those shapes that are filled in represent an individual affected by cystic fibrosis. Unfilled shapes are healthy individuals, and half-filled shapes are carriers. The shapes drawn in red for this example will indicate the information you gave me personally to work with, and the blue shapes will represent the genotypes I've determined from that information. The letters you see below the shapes are the genotypes mentioned, which indicate as well whether or not an individual is affected and if they are a carrier. Carlos, on your side of the family, you mentioned to me that your sister and your uncle on your father's side of the family both have cystic fibrosis. Seeing that your sister is unaffected, she has to have two little c alleles. In order for her to get two of the same allele, both your parents have to possess that allele, as each parent will only pass on one of their alleles from their genotype. However, since neither you or your parents are affected by cystic fibrosis, you each have a big C allele. As for your parents, that makes them both carriers. Your uncle's genotype in this matter is little c, just like your sister's. But it plays no real effect on your genotype, as we already know which alleles your parents possess. As a result, either of your parents could have given you a little c allele to go along with the big C allele that we know you already have, as you'll see later in the Punnett squares I'll show you. For right now, there's a 2 in 3 chance that you're a carrier, and a 1 in 3 chance that you're completely normal. As for you, Rebecca, you mentioned your maternal aunt has cystic fibrosis. Assuming you know your grandparents don't have cystic fibrosis, that means they're both carriers of the allele. Although one of them genealogically could be affected, one of them has to be a carrier, because your mother is not affected by the gene. From this, your mother, like Carlos, could have been passed down a little c allele from either parent. We can't tell. Likewise with your father, there's no evidence to indicate either way if he's a carrier. As a result, your genotype is also unknown, except for the big C that makes you a visually healthy individual. So, in essence, you could both be carriers, you could both be healthy, or one of you could be a carrier, and one of you could be healthy. It's hard to give a final percent probability either way, because as you'll see in a moment, Rebecca's parents are in the same predicament as the two of you are in now. What I can do, though, is show you the possibilities of each outcome and give an overall percent range of your chance to have a child with cystic fibrosis. Back on the board, I've laid out the 3 genotypic possibilities. Big C times big C if you're both healthy, big C and big C if you're both carriers, and big C times big C for a mix.
Remember, there are actually 4 possibilities on our mixed Punnett square, as either of you could be big C, little c. This is important because it slightly increases the chances of you being a mix of a healthy genotype and a carrier genotype. First off, as you can see in the big C times big C outcome, there is no little c allele to pass down, so 100% of your children would be perfectly healthy. As we move over to the big C times big C little c option, there is a 25% chance of having a healthy child, a 50% chance of having a carrier, and only a 25% chance of having a child with cystic fibrosis. All in all, if you're both carriers, there's a 75% chance to have a child who will not have cystic fibrosis. That's your worst case scenario. Finally, if only one of you is a carrier, you'll have a 50% chance of having a healthy child and a 50% chance of having a carrier.
This means that overall, you've got a 0 to 25% chance of having a child with cystic fibrosis, a 0 to 50% chance of having a carrier, and a 25 to 100% chance of having an entirely healthy child. The bad news is that in the case of your parents, who are both carriers, this means that most likely you are also a carrier. As for you, Rebecca, your genotype is still fairly undeterminable, as the overall ranges mentioned apply perfectly to you. However, what we can say from this is that your best case scenario, in which neither of you has the cystic fibrosis allele, is improbable. On the bright side, your second best case scenario would still not result in a child with cystic fibrosis. Having said all that, I would definitely recommend that you pursue actual genetic testing, as it would be able to give you a much more definitive answer than I've been able to. A standard genetic test consists of a sweat sample from a swab, and will be able to confirm whether or not either of you are carriers. Studies have shown that people who have cystic fibrosis have saltier sweat than those who don't. So, the sweat test measures the salt content of an individual's sweat. What's nice about the sweat test is that it can identify the specific mutation of cystic fibrosis that an individual is affected by. This is very valuable information, as different versions of the disease are more or less serious. Also, in the case of at least one known parental carrier, which will likely include between you, the sweat test can be performed on a fetus before it is born, allowing time for the parents to properly prepare. Nonetheless, if your child starts showing symptoms after birth, such as trouble breathing, a wet cough with a viscous mucus, and/or blood, chronic lung infection, failure to grow or gain weight, extreme difficulty digesting food, or if there's any suspicion at all of the child inheriting the allele from either parent, the sweat test can still be done. In the case of a newborn, the test can usually be scheduled within the first few weeks of life. The test procedure is very straightforward and is done by a trained technician. A unique gel is rubbed under the patient's arm or leg, and then covered by a small patch with wires for only about 5 minutes. Previous patients have said that the patch may feel warm or tingling, but will not hurt. At the end of 5 minutes, the technician will remove the patch and the sweat will be gathered on a gauze pad which is sent to the laboratory for testing. Typically, the results of the test are clearly discernible, but sometimes the salt content of the patient's sweat can cause morbidity, in which case it or another test, such as a blood sample, can be redundant. It takes about 1 hour for a patient to complete the test, and the results should be available to them in a day or so. Rarely, the child will be diagnosed cystic fibrosis transmembrane conductance regulator-related metabolic syndrome, or CRMS for short. This is when, despite additional testing, the child's results remain in the mid-range. These individuals are a recognized gray area in medical science, as they may never show symptoms of cystic fibrosis. They may show only a few symptoms, or they may develop symptoms later in life. Doctors recommend that children with CRMS receive follow-up testing yearly to monitor their condition. So that covers your genetic involvement with cystic fibrosis and the other tests that you have done. But I haven't mentioned much on the disease itself. As you likely know from your family histories, cystic fibrosis is a condition in which a person's mucus is unusually thick, causing it to hinder various passages of the body, such as the pancreatic duct, intestines, and lungs from clearing. This blockage can lead to serious breathing problems, lung disease, digestive problems, malnutrition, growth problems, and more. The silver lining, though, is that there have been tremendous scientific leaps in regards to cystic fibrosis in the last few decades. In fact, it wasn't even recognized as a disease until the late 1930s, and was diagnosed only after death from malnutrition or pneumonia. The problem with cystic fibrosis is that many of its early symptoms can easily be mistaken for other, more common conditions, such as asthma, chronic bronchitis, pneumonia, or celiac disease. Nowadays, however, there are many treatments that have been invented specifically for patients with cystic fibrosis. These treatments and medications have been able to greatly lengthen the life of an individual who is affected by the disease. First off, any individual with cystic fibrosis will require a long list of medications to treat lung infection, inflammation, and many other symptoms of cystic fibrosis. Mucolytics are used to loosen up the mucus in the lungs so that it can be coughed up with more ease. Bronchodilators expand a person's airways, which makes breathing a simpler task. Steroids reduce inflammation in the lungs, and antibiotics fight lung infections. The vast majority of these medications can be inhaled and nebulized, which yields fast results. Some, on the other hand, are also taken with IV or oral medication. In many cases, though, medication is not enough to efficiently clear the airways. In this situation, pieces of equipment are used on a regular basis in a variety of ways to temporarily clear the airways. One such method is a vest, which causes high-frequency oscillation in the walls of the chest. Another very important aspect of cystic fibrosis is nutrition. Since good nutrition can help fight off infections and maintain general good health, it is a very important thing to have under control. Oftentimes, with cystic fibrosis, people will require pancreatic enzyme supplements to digest food in a high-calorie diet, as well as vitamin supplements to maintain their weight and health. In the most severe cases, feeding tubes are used to directly transport nutrients into a person's digestive system. Finally, in the later stages of the disease, transplantations of certain organs may be able to fend off the illness. Current cystic fibrosis patients are offered double lung, heart, lung, and liver transplant. Of course, with advancing technology, new options will open up. One of these options may be gene therapy. It's important to note that this treatment is currently in its experimental phases and is not available, though it may be in the future. Essentially, the idea behind it is that by finding the defective gene in an individual, that gene can be replaced by a healthy gene, thus removing the disease. Germline gene therapy is a concept in which the results of the change will be passed down to future generations. And somatic gene therapy would affect only the person receiving the treatment. The problem with gene therapy right now is causing one normal gene to affect the entire population of the person's cells and not be inserted into just one cell. Instead, it must be placed on the separate chromosome. Cystic fibrosis gene is contained. Scientists are currently experimenting with a gene delivery vehicle called vectors that contain a human respiratory virus. By utilizing a respiratory virus as a method of transportation, they have managed to send the healthy gene directly into the lung. However, this does not solve the dilemma of placing the gene on the correct chromosome, and as such, cannot treat any other aspect of cystic fibrosis. Left to its own accord, the gene will typically insert itself randomly on the chromosome, the effects of which can help or hinder a person's situation. Due to the mixed results of this therapy, it can obviously not be released to the public. Researchers are unsure how long the results will last, or if they will need to be repeated at all, and many people are skeptical of the ethicality of permanently changing a gene. On the contrary, gene therapy does present a promisingly bright light that may become available to people with cystic fibrosis in years to come. As you've likely guessed, all this treatment can become a problem of its own for many families who deal with cystic fibrosis. The good news is that most provinces in Canada have partial or complete coverage, and only very few have none at all. It is necessary in many of these programs to pay a deductible or premium, which will be required before any assistance is provided. In cases where this coverage is incomplete, many families turn to private insurance or group benefit plans. If you ever find yourself in this situation, remember that it's important to read any insurance policies carefully, as they may have yearly or lifetime maximum. Another thing to remember is that not every drug is covered on every plan. The decision regarding whether or not a new drug will be added to the coverage list is made after an evaluation of its therapeutic value and cost effectiveness. For instance, Cystic, a new drug that has hit the shelves, is currently not covered by drug plans as a result of its cost. Although it's been described as very effective by the National Drug Review Panel, provincial drug plans have refused to pay for it at its current price of $300,000 per year. Sadly, despite all the treatments available today, the median predicted age for people with cystic fibrosis is only in the mid-30s. Nonetheless, the advances in technology have led to a steady rise of the median predicted age over the past years. About 60 years ago, it was assumed that children with cystic fibrosis would never go to school, as they would die before commitments. Now, I know this all must sound very dark and very horrible, but you have to remember that a lot of what I've gone over is the worst case scenario. In addition, your chances of encountering this problem, as I said before, are only 0 to 25%. I've taken all of these factors into account in a manner that suits the situation, and it is my professional opinion that you should go ahead and have kids. It's very unlikely that your child will have cystic fibrosis, and if they do, then you can deal with that obstacle as it comes. Regardless, having a child is a wonderful experience that is unlike any other, and I wholeheartedly believe that it is something the two of you should embrace. I wish you both the best of luck and encourage you not to worry about your history of cystic fibrosis.